You type a prompt, and a beautiful application appears in seconds. The dashboard is sleek, menus are populated, and buttons look ready to click. Then you try to actually use it. You attempt to filter a list or calculate a nutritional score, and the entire app freezes, loops, or shatters. If we lift up that front interface, we see exactly why it broke. There is no database. There is no logic connecting the pieces. It is a hollow wireframe sitting on top of nothing. Large language models are optimized to predict plausible sequences of text. They will gladly generate code that looks like a database query, but they do not inherently understand the structural architecture required to execute it. We call this confidence theater. The AI gives you a highly convincing simulation of a working system because it lacks the capacity to distinguish between a picture of a dashboard and a real aggregation model. You can spend weeks accumulating fake progress this way. And because you built a surface without a system, the only option when reality hits is a total unrecoverable rewrite. You cannot solve a structural collapse by writing more code or trying a better prompt. If an AI assistant cannot distinguish between a mock-up and a real system, the environment where you build has to enforce that distinction. FlightDeck acts as this governed control plane, a layer that anchors the AI to a set of hard architectural rules before it ever touches your codebase. The process starts with governance. FlightDeck forces your AI agents into alignment by dropping a behavioral contract into their operational memory. These rules strip away the AI's tendency to improvise. If the agent attempts an unauthorized architectural change, the system immediately blocks it. Binding the agent to an explicit operational agreement on day one ensures its output stays safe and structurally sound across the entire lifecycle. But controlling behavior is only half the equation. FlightDeck's primary defense is its pre-flight testing, a mandatory reality check that every idea must pass before the system clears it for execution. Consider a feature that scales recipes for a cooking app. A user might naturally type 2 cups sugar. To a human reader, that is clear, but a machine cannot execute deterministic math from a raw text string. FlightDeck catches this gap instantly, forcing you to decompose that string into 4 deterministic fields: quantity, unit, unit type, and ingredient. This validation extends beyond the data fields. The system checks if your declared database is actually connected, if your API keys are active, and if the app's logic can truly derive an output from the inputs you've provided. It tests the infrastructure and the logical viability of the concept, refusing to let a plan proceed until the math is defined and the system is real. Only after a concept survives this gauntlet does the system allow it onto the glide path. It becomes a formal specification, gets planified into sprints, and is finally handed to the AI for building. This completely shifts the point of failure. You catch the broken architecture on day 1 when it takes minutes to fix, instead of discovering it in month 3 when it kills the project. Compare that initial chat graveyard to a governed project. A founder booting up their FlightDeck cockpit sees their provider bindings for Vercel and Supabase active, verified, and ready. Every new session starts with rehydration. The system pulls perfect context from 3 specific tiers, instantly restoring all your project constraints, infrastructure rules, and behavioral contracts into the agent's memory. The resulting application has a visual surface inextricably linked to a working truth model. The data is machine usable, the authentication is real, and the calculations actually execute. True speed in software development is an illusion if it requires unwinding fake progress later. By trading the rush of an immediate hollow mock-up for the discipline of a governed glide path, you guarantee that you will arrive at a real, working product.